Hello, good day. Yeah, we continue with the solution to the problem, to the exercise we are working on randomized complete block design. From the last video, you will recall that we have this as our layout. From that video, we have the layout this way. So we have our treatments, we have the blocks, and we have the totals, block totals, treatment totals, just like this. And from that video also we had two sets of hypotheses. Hypothesis for treatments, null and alternative. Hypothesis also for blocks, null and alternative. So we are continuing with the computation. So we start with the computation, and as usual, the first thing we compute is our correction factor, which is CF. And don't forget the same formula as we did under completely randomized design. So it is grand total squared all over BT. In block design, the divisor is BT or N. You can also say that's or N. You are still correct if you use N or BT. So why BT? B stands for the number of blocks, where B is the number of blocks in the design, and your T, as usual, is the number of treatments. So we have how many blocks in this exercise? C1, C2, up to C5. So we have 5. So here our blocks is 5. And what of our T? The variety is there. We have 3. So in this exercise, our T is 3. So what's the grand total? The grand total is summation of all the individual raw values. And that is what we have here. If you look at the layout we have, that's the grand total. Totaling all the individual observations together. So in other words, it is equal to 37.0 plus 24.7 plus all through to the last value there plus 33.2. Everything after addition you square and you subtract now by, this will be 5 times 3. So this is the computation of the correction factor. And when you evaluate this, it will give you, of course, this is 450. Inside the bracket is 450, so squared all over 15. So to save time, I'll just go straight to what the answer is. 13500.0. Well, for consistency, I always prefer to do my computations to 2 decimal places. It's good to be consistent instead of doing some to 4, some to 2, some to 1. Just be consistent all through. Okay, so that's our correction factor. And for the sake of space, I'll just put that here. 13500.00. Next we compute is our SS total, like we did under CRD. SS total, as usual, is our individual observation squared. Then we sum everything. It has no divisor. We just subtract our correction factor. And of course, if you want to really write this as proper formula, the sigma will actually be 2. One will be for treatments, the other will be for blocks. Okay, so this gives us 37.0 squared. You square that value, that's the first observation, plus the second observation, which is 24.7. You also square it, plus you keep on doing that until you get to the last one, which is 33.2. So plus 33.2 also squared. So all this entity together, no divisor, just subtract your CF. And this is the CF, don't forget. So you estimate all this, and that will give you 14028, 14028.4. So to two decimal places we say 0.40. So we now subtract our 13500.00. And when you evaluate this, you will get 528.40. That's our SS total. Now, up to here, everything is exactly as we have done under CRD. Next thing under CRD, of course, we'll calculate SS treatment. So here also, let's do that. So we'll have SS treatments. And SS treatments, if you recall, it's usually the treatments, these are the three treatments. This, and that. So the totals are here. So, you know, it normally involves like that. They're all over B in this case, which is the number of blocks. So everything like that minus your CF. So what does this mean? To explain this, it means 156.9 squared. Let's leave a space so that you don't get confused with the clumsy nature. So 156.9 squared plus 148.6 squared plus 144.5. 144.5 squared. So that's all. Everything now divide by number of blocks, which is 5. And then the whole thing minus your CF. So that's how you calculate the SS treatment. Just the same way as you do under CRD. So up to here, the calculation is still the same, up to here. But then, when you evaluate this, the final answer you will get is for the, maybe I should write it here, 15.98 as the final answer. Sorry, not 8.96. Okay, so 15.96, that's the answer. When you evaluate this expression, it will give you that. So up to here, all we have done is exactly as we did for CRD. But what separates CRD from RCBD is that there is an additional source of variation in the experiment, as we discussed in the last video. And that is variation due to blocks. So to be able to capture that, we will also compute sum of squares for blocks. And that's the next thing we want to quickly do. So how do we do that? It is expressed simply as SS blocks. SS blocks, which is computed as summation of the B-high squares all over T, which is the number of treatments. And the whole of that, subtract your CF from it. So what does this mean? This means our block totals, each of them will be squared and added together. So here are the BIs, the block totals. So we'll say this is equal to 115.2 squared plus 74.1 squared plus 70.1 squared plus 90.7 squared, and finally plus 99.9 squared. Everything will be divided by t, and our t in this case, number of treatments, 1, 2, 3. We divide that by 3, and the whole expression will subtract our correction factor, which had earlier been computed. So with this formula, we are ready for our SS blocks. That's the blocks sum of squares. And if we compute this expression, it will give us 460.79. That's the final answer for that SS blocks. So now we have computed the sum of squares for the various orders of variation, remaining the error sum of squares, which is normally expressed as SS error. And what's our SS error? SS error is simply SS total minus all the other SS. So it's minus our SS blocks minus our SS treatments. Now, it doesn't matter whether you say it is SS total minus SS blocks minus SS treatment, or you put treatment first by saying SS total minus SS treatment minus SS blocks. Is the same thing. So when you subtract all those sums of squares from the SS total, the final answer it will give you is 51.65. That's the final answer for the SS error that you will have. Now, having obtained this, all the other computations will be done in the ANOVA table, and that's what we will treat in the next video. See you in the next video. Thanks for watching.